Hello everyone, and welcome to the Stanthorpe online Future Orchards Walks. For those of you who don't know me, my name is Rose Daniel and I'm the Technical Manager with APAL. We're sorry we can't be there with you in person, but we're happy that we can still present the Future Orchards program. The online option also means that we can share with you some of the leading orchards from New Zealand. Today's theme is The Future is Now. You'll be hearing from Dr. Nigel Schwartz from TIA, who will present a summary on the learnings from the PIPS2 fertigation research project and launch the SINATA tool. Jonathan Brooks from AgFirst will explore current and future issues such as labour, trees, quality, climate and technology. Your FLE, Stephen Tancred, will provide an update on the latest demonstration trials being run in Stanthorpe, and Jonathan Brooks will then take us on an orchard tour of several leading New Zealand orchards. I'd like to just share with you some of the activities that APAL has been working on over the last few months. We've been working with the bushfire affected regions and assessing fire damage to submit a request for support to the government. We've also been developing a biosecurity preparedness framework for APAL. APAL staff have now been trained in the emergency plant pest response deed, and we're in the process of developing a standard operating procedure in the event that an incursion does occur, so that we're more prepared in that event. We are also piloting a tree census project. We realised in responding to emergencies such as the bushfire emergency that we really needed good data about the trees and orchard sizes and things like that, so that we could respond more efficiently and more effectively. We're also in the process of planning the next round of future orchards. If you've got any comments about this current round or any ideas that you'd like to share with us about future rounds, please get in touch with us if you've got any feedback. Okay, so without further ado, I would like to introduce Nigel Schwartz, who will present outcomes from his research into the improved water and nutrient use efficiency for apple orcharding. Nigel is a research fellow in the Tasmanian Institute of Agriculture at the University of Tasmania. His research expertise is in the field of tree physiology and tree crop nutrition, and he leads the fertigation project for the Hort Innovation at Apple and Pear levy-funded PIPS2 program. Nigel, it is now my pleasure to hand over to you.
Good morning, everyone. Thanks so much for joining us this morning, and it's a real pleasure, a privilege that I've got to be able to present, I guess, the culmination of the last 3 or 4 years of our work at TIA and also across the country working on apples. And this, by no means, is just my work. This is a combination of work by Plant and Food Research fellow Steve Green. Marcus Hardy from TIA is our soil physiologist, and B. Zhang Tan is our PhD student who's done a lot of the nitrogen work that I'm about to present. And also sort of overarching supervision from Dougal Close, who is our a research fellow or professor at TIA. And yeah, look, essentially what I want to do this morning is just take you through the last 3 or 4 years of what we've been doing and wrap that up into our kind of user-friendly tool, SINATA. Obviously, we would have much rather been face-to-face with you this morning. We would have been able to deliver live an Excel spreadsheet that we can take you through how the tool works. But instead, we've sort of got 20 minutes. There's a whole stack of background that we're going to sort of park and leave, but hopefully through some screenshots, you'll get a bit of a feel of what the story is around this tool. So SINATA is the primary model, which is sort of coming out of this project. It's an online tool in Excel, and it stands for the Strategic Irrigation and Nitrogen Assessment Tool for Apples. SINATA is a decision support tool that will guide advisors and growers on the optimisation of irrigation and nitrogen application for the major apple growing regions across Australia. I guess the real aim and focus of SINATA is to really try and understand how water and fertiliser applications, particularly nitrogen, type of nitrogen rates and timing, can be managed to satisfy tree demand, mitigate leaching and optimise productivity without a cost of fruit quality. So this is really all about trying to understand the environmental footprint of apple growing, essentially when it comes to nitrogen and water. The model requires climate and soil data, and these are all based on local databases and characterization. And it also requires input from growers and advisors about tree variety, yields, and some of your various aspects of management. But just to, I guess, get a bit of a grasp about what SINATA is all about, we need to kind of just touch base on some of the, I guess, nitrogen physiology of deciduous apple trees or apple trees. Apple trees being a deciduous system, obviously we're at the time of the year now where the leaves have fallen off, the nitrogen has been withdrawn from the leaves into storage organs over the winter dormancy period. That winter nitrogen storage is the, I guess, provides that remobilization nitrogen for first, I guess, 2 months of season's growth in spring. And that really gets us going, gets the trees going right through until about 1 month after full bloom. And it's about that time when roots start taking up nitrogen from the soil. And that's really important for us to realize that, because there's a really quite a big component of your nitrogen budget that is contained within and recycled from season to season within an apple tree. And then that internal nitrogen recycling, together with the amount of nitrogen that gets taken up from the soil through mineralization, and then gets removed by the tree during harvest, when crop removal, when 80 to 90 tons a hectare are taken off from the tree, relative to the amount of nitrogen that gets put on through fertilizer, is kind of our good understanding of nitrogen use efficiency. And that's what we're really trying to optimize through the work that we're doing here. So on that top right, you can see that sort of apple removal, the crop removal, plus nitrogen that's stored in the tree, relative to the nitrogen that gets put on, is our understanding of NUE. And then below that is how we've really tried to grasp the idea of how much water an apple tree uses. So we've done that through sap flow measurements. We've looked at heat pulses in young trees and in mature trees. So young trees that have only just been put in the ground through to when they got to 3 or 4 years old and started cropping. And then other trees that were 9 to 10 years old, had a full canopy, and were yielding 70 to 80 tonne a hectare. We now have a really good understanding of how much water those trees use as well over the course of 2 or 3 seasons. But the authenticity of the model and the way this tool is going to work is really underpinned by how water moves through the soil. So how tightly held the water is in the soil, what that soil type is that you're growing apples in. And so to get a grasp on that, we've gone around to 4 major apple growing regions. We only had budget from Hort Innovation to go to 4 regions, and we actually haven't got up to Stanthorpe yet, and we're hoping that still might be a possibility down the track. But in each of these regions, we looked at about 31 different blocks, and we described them off. We dug big trenches and excavated a pit, and we looked at the morphology of the soil, took lots of photos, the chemistry of the soil, and then most importantly, we looked at the hydrology, so how water moves through that soil, how much water that soil can hold. And then with all these things combined, we made some recommendations about the management of that soil and how to improve soil health in that context. And all this information is contained on the applesoils.com website, and that's on the APAL, there's a link on the APAL website. What is really important actually then is then how this is inputted into the tool. So the tool comes preloaded with the range of soils from across the apple growing regions in the country. A pull down menu on one of the screens is used to select your chosen soil series. We have about 22 different soils coming from the PIPS2 soil surveys, and these are all described on the Apple Soils webpage. So a grower can go onto that Apple Soils webpage, have a bit of a look at what a soil in their orchard could look like based on the pictures on the website, and then click what they think it's most likely going to resemble based on the colours or based on what you know of what your soil is. and you can upload that, or you can select that as your potential soil type. And with that comes a whole stack of measurements from your organic nitrogen content, organic carbon content, clay, sand, and the saturation point. And all that's really important for how we understand water moving through the soil. And then a whole stack of other data has come from the Victorian Soils database. Now, what's also really important is that I'm really keen to hear from growers in the Stanthorpe area, from those who have done soil testing, or those who have done some really good and thorough soil, I guess, morphology descriptions, or they've got an understanding of their hydrology. I'd love to get input from growers and that data, so that I can upload that into the web page, because into the tool, because the more data we have, the more powerful it is. So that's the soil story. The other part of the story is the climate. So the software is preloaded, or so that the tool is preloaded with historical data from 22 climate stations. These have been downloaded from the Australian Bureau of Meteorology database. And these records include daily values of ETO, air temperature, rainfall for the harvest seasons from 2000 until 2018. Look, I mean, all this information is hidden, but you get the idea. And essentially, all you have to do is just pick a climate area that's closest to you. And again, the more data we have, if we can get historical records from growers on farms and have access to that data for these data points, then we can input that function straight into the tool. The more data we have, the more powerful the tool is. So very keen to hear from growers on that. And so moving on to the next slide. So these are kind of, that soil and that climate is the background data to trying to, I guess, really the power of the tool, the power of the model. And then what's really important for us to understand is how tree water use is calculated. So this is calculated in the tool, in SINATA, using the local climate and age-derived crop factor. It uses a big leaf description of the tree canopy, and that description is parameterized by an empirical crop factor, which is KC. You'll probably all have an understanding of that, and that's related to the leaf area index of the orchard. So leaf area index is the area of leaf per unit ground area of the orchard. A standard crop factor of approach is used to relate a tree water use to the prevailing microclimate and physiological time of development, and I'm going to get to that in a minute. So, you know, where also the power of this tool has come from is from OrchardNet. And again, the more data we have in OrchardNet, the more power we can obtain to, I guess, parameterize the model. So we utilized OrchardNet for apple yields across the region. So we had really solid data on 4 main varieties, grannies and pink ladies and galas and galaxies. And what we did is I mean, you can see all those data points there in that top chart, and all that has come from growers' orchards over the last 10 years or so, since, or however long OrchardNet's been going for. And you can really see that, you know, it's really at about 10 years where that line plateaus, where growers are starting to get somewhere between 75 to 100 tonnes a hectare for grannies. And that happens a lot quicker for pink ladies, where you're up to 75 to 100 tonnes a hectare after 5 years. So this is really important for us to derive an age relationship for yield and develop some average and upper quartiles for the data set. So the other thing associated with OrchardNet there is you've got the option to input a whole stack of phenological time frame data into when your apple trees start flowering, when you've harvested, and other different stages of bud burst of during the season. And that data is critical for us to be able to develop some phenological time frame functions. So the next stage is really, I guess, really trying to understand how an apple tree uses nitrogen over a season. And that's really critical for us to, I guess, parameterize the model. So we've done that by applying nitrogen fertilizer as 15N. So 15N is a nitrogen tracer. It's a stable isotope of the 14N of nitrogen, and it allows us, if we label a fertilizer, say calcium nitrate, for example, with 15N, we can then track that movement of nitrogen from the fertigation dripper system into the tree and anything that leaches below the tree through in lysimeters or in the soil or however that's going to work. So we did this over 2 or 3 seasons, and that chart on the left here, and we also trialed different treatments as well. We trialed a full rate pre-harvest of about 50 units a hectare. We trialed a full rate post-harvest, and we trialed a 50-50 rate. So we split 25 units pre-harvest, 25 units post-harvest. And then we had a 0N control. And so obviously, I mean, all this data is very familiar to you. We're up to about, I mean, this is in the lamina, by the way. So this is the nitrogen that's stored in the leaf. This is not in the PDL. But we're up to about 2.4% nitrogen content. This is in a gala. This weeks after fertigation. The fertigation started mid-November. Don't forget we're in Hobart in the Huon Valley here, so we're a bit later than you guys. And that continued right through until leaf fall at about week 23. And you can really see at about week 19 here, week 20, it was at that point when the fruit came off the tree. So, I mean, I think this is a really powerful indicator of how strong a sink fruit is for nitrogen. And this is where we have to be careful about how much nitrogen goes on post-harvest. Whilst I'm advocating post-harvest, pre-harvest application, we need to be careful how much goes on because this fruit is such a strong sink. And as soon as that fruit was removed, all of a sudden that nitrogen get remobilized back into the leaves as well. And that slide on the right here if you look at the green, that's the full rate, that's the 15N, that's the fertilizer N component of the leaf. And then the gray line is the 50-50 part. And then the real interesting thing is the orange line. So the orange line is the post-harvest application. So the fruit had come off in early March, and we applied nitrogen at that point. And you can really see that there was very, very little uptake of that 50 units a hectare into the leaf canopy. And that's not so surprising because once the fruit have removed, there's very little physiological demand for nitrogen up into the canopy. But from an efficiency point of view, this is really important. So the other aspect of trying to understand where nitrogen gets stored and partitioned is looking at a spring versus summer partitioning chart. So in dormancy of 2017 and 2018, we excavated a whole stack of trees, fully excavated, and we split them all up into their different organs. And we looked at how much nitrogen that came from fertilizer had been partitioned to the tree organs. And what is really fascinating is if you look down the bottom here, that pie chart on the left, 9.7 grams of nitrogen per tree came from the pre-harvest application, of which about 50% of that fertilizer nitrogen was held in the fruit. And then the post-harvest application was about 5.3 grams of nitrogen. So that was like 50% less, almost 50% less of nitrogen that were taken up and partitioned throughout the whole tree. And obviously, post-harvest, so there's no nitrogen in the fruit. But what is really important to show is that in this chart on the left, that pre-harvest nitrogen made an important contribution to all the storage organs. So all the storage organs are the ones here on the left-hand side of the pie chart. So the blue's the root, pink here is the trunk. These are storage organs. And in fact, given that the total amount was 9.7 grams of N per tree, 14.7% is about the similar to 41% of 5.3 grams of N per tree. So we can meet fruit quality demands. We can meet tree storage demands through a pre-harvest application of nitrogen at a much lower rate than what you normally would put on. So, this is what we're advocating, because from a nitrogen use efficiency point of view, we can be a lot more efficient with a pre-harvest application. So then what have we done with this data? Well, what we've done is we've developed nitrogen demand curves for leaf and fruit development obtained by a least square fit to this experimental data. We've done that for leaf and we've done that for fruit. Leaf data is a function of days after bud burst, and these can be rescaled using growing degree days for other locations. And it's the same story for fruit. Fruit data is a function of days after flowering, and these can be also rescaled using growing degree days. And honestly, the length of harvest window and anything that we've got in OrchardNet is critical for us to be able to fill these knowledge gaps for other varieties as well. Okay, so let's take you over to the tool. And so what I've got here is I can't actually give you an Excel sheet to play with at the moment, because we've only got 20 minutes and I've probably already used most of that time just giving you some of these other details. And I'd really love to be able to sit there and pour over the Excel sheet with you. But essentially what we need to do, and here's a screenshot of the inputs, we need to input our apple variety, input the tree age, input your plant spacing, your tree spacing in your orchard, and your row width. And then what's really important for us to understand is your irrigation infrastructure, whether you've got microjet or whether you've got drippers, the rate, emitter spacing, duration of these events, and your likely return period. So, the frequency of irrigation. And you've got the option there of whether you want to see the units in either megalitres or millimetres, whatever you prefer to, however you understand it. And then you then can have a look at, you can press to update then, and then this will calculate essentially from all the historical data in OrchardNet, your expected yield tonnes a hectare. It will also calculate the amount of nitrogen that gets removed from the crop every season. So this number 22 is really 22 units a hectare gets removed from your orchard every year in this scenario of a 6-year-old Fuji tree, 2 meters by 4 meters with a 50 tonne a hectare crop. We also know that your trees are going to be using about 46 kilograms of nitrogen per hectare. And we've got some estimates on bud burst dates, flowering dates, and harvest date of year. Now, this also will give us a bit of an understanding of how much water your soil can hold. So, for example, at this site, we've got 403 millimeters as a fill capacity, and then 335 is your refill point and wilting point. And this is really important information for you for your irrigation scheduling. Okay, so what's these are some of the outputs that this is going to show. So first of all, for the purpose of this demonstration, we want to show you a few worksheets from SINATA that will be used to select the climate and soil data, and obviously display the water use as a function of factors of your tree age, variety, and planting density. You've selected your climate, you selected your soil already. Then the software estimates tree water use, and so this is the top graph up here. This has come from all our sap flow records, and then the bottom chart here is tree water use in liters per tree. So we know for example at Tatura with a Goulburn loam soil type, the average over the last 20 years was about 457 millimeters of rain. The ETO is about 1230 millimeters. The ETC is about 605, and the irrigation to meet tree demand for the annual water balance is about 412 millimeters. And this can be used to do your irrigation scheduling. So that 412 millimeters, for example, is split up into, and the bottom right blue chart here is split into how much water is likely to be required in your orchard from September through to April. And this is going to obviously vary based on wherever you are, your crop load, your variety, et cetera, et cetera, et cetera. And so there's some other data there on your ETO and rainfall by month, but the real critical thing here is this bottom left chart. And the green is the really important aspect, because that's your tree water use, and then your red is the irrigation to meet that tree water use together with the other water that gets removed through your ETO. And so these are sort of scenarios that you can play around with when you have the Excel spreadsheet in your hand. But I also want to then move down to Grove. So we've kept the soil type the same, but Grove really shows you the difference in the amount of rainfall that you get. So we get 754 mils of rain, which means that irrigation volume and amount is a lot less, with the same tree, the same age, same crop expectation. And then you can see the distribution of irrigation, expected irrigation changes as well. Now, what's really difficult for us to do here is do a real-time irrigation schedule. So we can't go, oh, gee, it's been a bit drier in October, November. Therefore, what happens next? We can't do that yet. That is the plan, and we're hoping to do that for this next stage of the project, which is, if that ends up happening, that'll be the next 3 years where we're really going to try and develop a real-time web app that integrates all growers' soil moisture data with their climate data to develop a real-time irrigation scheduling software together with all this SINATA background. So, look, it's probably quite overwhelming, and it's really hard to get, in 20 minutes to get your head around exactly what we are looking at here. But the plan will be to walk advisors through this, walk growers through this. I'm really keen to get growers to get in touch with me and talk about the data that they've got from their farms, anything that they want to assess, any sort of scenario analysis and planning. I really want feedback on what is important for growers in this space, what's just not likely to work, and what could be included. We do have some knowledge gaps. A tool that has a model background is only as good as the data that you have to parameterize it. So, root depth, and you've got all sorts of soil restrictions that we don't know about compaction on your orchard. We don't know necessarily about your root depth factors that we just have to estimate. And we want to be able to develop flexibility to adjust irrigation set points. So, what is your strategy for irrigation? And we want to know, if you want this tonnage of crop, how much water it's going to require. And we want to know how you guys think it's better to irrigate to get to that point. So then we've got flexibility to build into that tool. And then there's real opportunities for metrics. So understanding water use efficiency and doing a cost-benefit analysis on the amount of water that's required to develop and produce the crop that's going to come off that orchard. Look, I've probably gone well over time. I might just leave it at that. Very happy to take questions. Very happy to, have conversations with growers, and please get in touch.
Apologies for that. Thanks very much, Nigel. Does anybody have any questions? If you do, please either let Stephen know or Simon know, or type it into the Q&A bubble at the bottom of your screen. For the person that's called in on the phone, I know you can't see the screen, but these presentations will be available afterwards for you to have a look at if you would like to do that. While we're waiting for questions, unless someone with you, Stephen, has a question that they'd like to ask.
Rose, can you hear me?
Yes, I can. Yes.
Just a comment, Nigel. I've got 25 or 30 years of leaf tests and soil tests. If you want access to them, you're welcome.
Oh, that would be brilliant, Steve. Thank you so very much.
Yeah, I'll take you to lunch too. And the farmers here do a lot of soil moisture monitoring.
Yes.
And I'm sure we could find some that would give you access to their records about evaporation, moisture use, root depth, etc. So when you're up, we got plenty of stuff here for you to tailor it to our soil type.
Yeah, and look, I absolutely agree. It would have been absolutely fantastic to have a Stanthorpe soil type in there, and also to have, in your water situation, to have a really good handle on what's going on with how your trees are managing these water shortages, and how you can, what's your best and most efficient irrigation strategy to meet, with your limited water to meet tree demand, would be really, really great to have. So the more data I can get from you guys, and maybe once all this COVID stuff gets done and dusted, maybe I can come up and actually have a chat and sit in that room with you guys and your growers and pour over this spreadsheet. I think that'd be really great.
That sounds like a very good idea. Does anybody else have any questions? How adaptable is the model to erratic climate conditions? I guess, you know, obviously Stanthorpe has been in fairly severe drought conditions for some time. Other areas, apple growing regions such as Orange, are also sort of suffering from water stress.
Yeah.
So,
Yeah, so I mean that's why we've limited our long-term average calculation to the last 20 years, because we do know that things have changed a lot over the last 20 years. So we are limited by the fact that we can only average for the last 20 years. We can't do any forecasting yet. However, the plan is to be able to link into the BOM forecasting database and be able to have real-time data from you know, a week to 10 days in advance, together with all this background information and on growers' soil types and tree water use, etc., to then be able to have a real-time schedule, I guess, and then be fully adaptable.
that sounds great. Are there any more questions from your room there, Stephen?
No, they've all said no.
Great. Okay. We might move on to Jonathan then. Thanks very much, Nigel. And I'm sure if anybody does have any data, please get in touch with Nigel. He'd be very appreciative of that.
Thanks, everyone.
Okay, it's now my pleasure to introduce our next speaker, Jonathan Brooks, who I'm sure many of you already know. He will speak about the future orchards, where we are now and where we're going. Jonathan has been involved in the New Zealand horticultural industry for more than 30 years and has a strong practical knowledge of pip fruit. He specialises in helping professional growers identify and monitor key performance indicators for the orchard business to find practical, cost-effective solutions to help lift performance and optimise profitability. So Jonathan, I'll hand over to you now.
Thank you very much. Yeah, so what we're going to cover off today is basically what is future excellence, both now and into the future. So it's a combination of all of the last 4 years of Future Orchards meetings that we've had, and I've got to try and put it together into 20 minutes, so we'll get underway. So effectively what we're talking about when we look at excuse me, I've just got another one here. When we're looking at the first Future Orchards program, it's been a highlighted number of those number of years, and it's looking at quality, climate, trees, labour and technology. The success of the orchards will be based on ensuring all of these topics are done well and there's no weak links. So each one of these topics is as important as the other, and we've just got to make sure that when we're focusing on it, we're not just focused on one area, we're focusing on all of it. So the first one that I want to cover off is the quality aspect. So fruit quality is basically a mindset. If you're not looking at actively trying to target what the consumer wants, you're basically going to be left behind. You know, quality doesn't mean the same thing to all customers, and if you don't understand your target customer, you basically can't target the quality they need, and that's a key part of actually going through. You know, it's not just one thing; it's multiple different things that make up this whole embodiment of quality. So to actually understand what quality is about, we need to make sure that we're actually becoming closer to the customers. You know, growers need to be able to get feedback from the customers, whether that be positive and negative, and then basically supply what they're looking for. It's about seamless information through the supply chain, making sure that you are getting that information right through and it's not stopping at certain areas. It's getting through from the marketing people through the pack house and straight through to the grower. Then we need to spend time listening and learning, and we also need to make sure that we're adjusting the orchards to suit the market wants, and then just continuously improving from there. So as I said before, quality can take many forms. It doesn't really matter if it's bitter pit from poor pruning or low crop loads or low calcium levels, or damage caused by pest or disease. or increased colour demands, that the market's pushing through. So all of these things basically need grower understanding, and they all need focus from growers to make sure we're delivering what it is that consumers actually looking for. So the other way that we can look at quality as well is we can look at variety and company standards, variety clubs and marketing groups can help growers with systems and market access and variety brand management. We need to actually understand all of this stuff, but the important thing is that these things do come at a cost, and eventually they've got to actually add value to the grower bottom line. All of these things are all quite important, but if it's not making more money to you as a grower, it needs to come with correct balance for sure. So again, when we're looking at quality, customer is basically the king or the queen. To be successful for the future, it's critical that you know your customer, and the orchard decisions you're making must consider the impacts on this customer. So the next one I'm going to cover off, which is one of the next years that we went through, was managing climate. And of course, in Stanthorpe, really, really important, and it's a key area where you guys are well and truly aware of this. So when we actually designing our orchards, we need to make sure that we've got orchards that are actually got a full understanding of the orchard location and the risks that come with it. And it doesn't matter whether it's winter chill or frost, hail, heat, drought, all of those things. We need to be planting the right crops, varieties, and the right systems for the location. We need to be farming how and where it's suitable to do so, and making decisions targeting production and quality alongside the best fit with the natural environment. So when we're summarising the climate, the risk or reward from climate, is really, really important to understand the orchard business. And when I say reward, there is things that come with climate that do actually add up. And if it's an advantage with you and your location, you really want to be working on that and taking that to the nth degree. Each orchard situation needs to be understood. You need to be doing some measurement stuff, and as we saw before, understanding what the seasonal risk is, including what the potential is from a short and long term, to understand those and try and minimise those negative effects. Again, create a climate management system that has the best fit for all of your blocks. So next we're going to cover off is the variety choice and the orchard systems. This is an interesting area. It has a lot of opinions about what's right and what's wrong. It's plagued by trends and newfangled fashions, and it needs to be done right and at the right speed. What we need to be understanding is it needs to be a continuous improvement focus. And as I said, the variety choice does change constantly through time. We need to understand the risks and rewards of change, and both of them are important. We need to be seizing opportunities, and we need to be understanding that doing nothing is not an option for the future as well. So while we can change and get ourselves in real trouble by changing too fast, doing nothing is not a choice. So when we're talking about new varieties, you probably all seen this decision matrix before that I've presented. What we did here is try to break down effectively some of these things that were really important when we were making decisions. And the first area here is about the market fit. Choosing a new variety needs to be understanding what the quality attributes of the variety are, the market potential, variety accessibility, and supply timing, all those things for the market. The next one is the financial fit, the returns, the variety risk, production potential, all of those things. And the third part was actually the orchard location fit. And that's understanding the climate stuff, harvest timing, pest and disease, and tree availability. So all of those things need to be put together. You've got to make sure that it's suiting the markets, harvest timings, financially it makes some sense, how it fits into my risk profile, location, and the other thing which is quite important for a lot of people is making sure it comes with a team of people that you're dealing with, that you're happy to work with, and that's not always the case. And that's what helps us to make the best choice for the new varieties. So along with that, you're actually talking about canopy design. And within the canopy design, it's about function and personal preference. One thing that's really critical, if you don't believe in the system, it's guaranteed to fail. So whether it be the impact on quality, whether it be the requirements such as netting, snow, yield potential, all of those things are really important, but some are more important to others. So, and specific to your location. So it is a personal preference, and there can be more than one right system. And that's it's a key thing, I think, for growers of the future, is understanding that just because your neighbour's doing something or someone down the road's doing something doesn't necessarily mean it's a perfect fit for you. So when you're talking about systems, you were talking about all sorts of things. It could be a V-trellis, it could be the 2D systems that we'll see in the video later, it could be the FOPs, it could be just a good slender spindle that's doing high production and it's pretty well understood. Each system does work, and it's important that it works for growers as long as they are focused believers. If they believe in the system, that's fine. If you try and push a system onto someone that doesn't believe, it's guaranteed to fail. So when we're talking about modern systems, I think it's important that you have some overarching rules, and that doesn't really matter whether it's stuff that Craig talks a lot about, the simple, narrow, accessible, productive, the SNAP stuff, or another acronym I pulled in was this LOVE'em, all about making sure you've got the right light capture of optimum yield and vigor, variability, elimination of limiting factors, and making sure it's got good management potential. So out of all of that, you just need to make sure that you're selecting a growing system that has the best fit for your site and your overall business. So this is a key area that I'm really interested in, is making sure that you're actually keeping up to date with the existing orchards. So not just chasing the rainbows of the new things coming through, but ensuring that the blocks that you do have existing, that they're doing the best that they can be. So making sure you're monitoring the block performance, so you know what's going on, and then updating to make sure that each block is working to its potential. And then you are upgrading, but you're upgrading your orchard at the right speed. We work on sort of 5 to 15% turnover in a year, no more than that. And then just keeping your eyes and your ears open for improvements. And they can be little things, but little things do matter, and they do add up. So one of the key bits is, this is not the future. 30 to 40 tonnes per hectare is not going to be sustainable for the future. We need to make sure that we are targeting those higher production, high quality, good systems that can produce yield year in, year out. When we're talking about canopies, we need to make sure those canopies are the right varieties and they're all part of a system. They're all links in the chain and they're all strong. They need to be focused on climate, quality, production profitability, and task efficiency, making sure that they are sort of set up so that you can do things like labour and bits and pieces as efficiently as you can. So that's the next one we're going to cover off, is labour and task management. So when we're talking about labour, we need to make sure that we've got a continuous improvement focus on labour tasks. Labour is a huge cost of growing, and it's a low-hanging fruit. We need to ensure that we're doing it correctly. Seasonal labour, as I said, it's the biggest cost. It's about planning, systemisation, monitoring and management. It's making sure that you're going through the whole labour process and understanding how it should be done and making sure it's being done correctly. When you're looking at solutions, it's about short and long-term solutions. And then making sure that you are understanding the big picture impact of what labour is actually meaning. And that could be through the season. So sometimes a focus on doing a project or doing a task early in the season can have a very large implication on later in the season. Especially things like right now when we're thinking about pruning, doesn't seem particularly urgent, but making sure you're doing a good job of that now can make your hand thinning much easier, can make your harvest much easier. So it's just understanding what the implications are right through the season and beyond. So when we're talking about short-term solutions, it's about creating plans. It's about actually making sure that you've got good pruning plans, thinning plans, harvest plans. It's about measuring and monitoring and making sure that you understand what are the things you're actually looking for. We need to make sure we get clear instructions. And as I said before, tasks done well early, such as pruning, can often make it easier or cheaper later on. So we need to understand and assess how they're carried out correctly. What is the price and what is the quality of the labour job or labour task that we're doing? We need to minimise the worker decisions, and keep it simple. So how many branches, how much detail, what are we trying to achieve? But don't make it overcomplicated. Then also we need to understand about additional tools. So not just the task of pruning, but what implication is that likely to have? Is it likely to reduce vigour? Do we need to think about dormancy breakers? Do we need to think about colour enhancement later on? All of these things that tie in together with the tasks that we're doing. So lots of small gains add up. So it's a continuum of a system. So when we're talking long-term labour solutions, it's about orchard systems. So it's about genetics and varieties, making sure that you have got the best that's available. It's potentially thinking in the future robotics or sensor assessment will become part and parcel of our normal day-to-day business. So we need to understand that part of improving our labour is to make sure that we've got those sort of things coming through. And then it's making sure that we've got excellent canopies. Excellent canopies with fruits in the right place, getting good light, and with the right crop load and vigour, so we reduce waste. So when we're talking about improving labour productivity, we need to understand what it is that changes worker potential. So when you're doing a job, it's the distance you're travelling, it's how tired you become, how easy or motivated you can be to carry it on. It's the instruction that you're given or getting as the person doing the task. Conditions, all of those things are highly important. So what we need to understand is if we want to improve the output rate, we either need to change the worker or we need to change the working conditions. So talking about changing the worker, I'm pretty sure that this worker is much more efficient at picking apples than a Kiwi would be, able to reach nice and high with a built-in tool pouch or picking bucket. The key part is it's a bit hard to give them clear and simple instruction. We need to think about efficient and effective training, minimum movements, how to read trees, whether it be pruning or thinning or harvest, and then how to use equipment correctly if we need to use equipment, and then make sure that the workers that we're using are motivated to do the work they want and motivated to work hard. And that can be a key part just in its own right too. And then make sure the work is being checked. Often I see a situation where we set up systems so we know what we should be counting, we know what should be happening, whether it be thinning or pruning or anything like that, and you go back later on and you have a certain number that need to be on a tree, and the number's completely different. And you say, well, who told the pruner or the thinner that that's what was meant to happen? They said, oh, well, no, they finished the block, it's all done. So, yeah, I think workers can't change unless they're getting good feedback. So then we can change the work, so not just changing the worker. So, you know, pretty common for us to be looking at people on ladders, and, you know, it's pretty much the norm for us here in New Zealand at the moment, but if you want to make things more efficient, you know, there's potential in some blocks that this is going to be a better way to be doing it. You know, we need to understand about minimal movement. You don't have to walk up and down Everest if you're using one of a platform such as this. It's slightly more motivated environment. It's not quite so hard, and you can use a bigger selection of people, and it's just a bit more simplified. The other thing with platforms such as this, it potentially needs to be understood that it can be used for multiple different tasks. So whether you can use it for tree training, or for tying, or for pruning, or harvest, or whatever it is, what you need to understand is that these sort of things, these sort of changing the work options, need to be specific for specific orchard businesses. Right? Something that's on hillsides or in different situations, you know, potentially this might not work, and you might have to find other options. So it's about finding what fits for your specific orchard. So when we're talking people, you know, when we're talking about all of the jobs we're doing, how do we find the people we're actually looking for? You know, we in the past have been relying a lot on things like grey nomads and people coming through that are tourists and having a bit of fun turning around. In New Zealand, we use the RSC scheme, or the workplace seasonal island workers, whether it's local workers. What is it we need to do to find and keep them? I mean, I know on cold days, it's amazing how a warm sausage roll or a warm pie on a cold day can motivate people. Is it the money? What is it we have to do to make sure we've got the right people and they're able to do the right job? And the next thing is, you know, what's COVID-19 going to do? At the moment, you know, we aren't getting the tourists coming in. So there's likely to be less tourists, less seasonal workers. And also, there's potentially more unemployed people looking for it. So maybe that's an option. That comes with its own baggage as well. And then the worker hygiene challenges that potentially we've got to think about too. So, you know, things are changing, and we've just got to try and make sure that we keep up with those changes. So in summary on labour, you know, it's focus on continuous improvement. We need to plan, systemize, monitor, and manage. You know, we need to think about the right job, think about the right price, and we need to think about the right people. So the next one I want to cover off is technology. So technology is another key part. Implementation of the correct technology is going to be very important in long-term sustainability of the orchard businesses. And it doesn't really matter whether it's at picking or making the picking better, by leaf plucking, or mapping areas where you can change things that are going on in the orchard, or even reading what's going on, or things like OrchardNet, where you're actually able to collect block information and benchmark and use that as a management tool. All of those things are important, and they're all going to be key for the long term. And when we look at the technology potentially that's coming through, now there's all sorts of things. There's sensor technology, there's bits and pieces on data management like OrchardNet stuff, automation, design. All of these things are really, really critical, but it is important that we understand what's coming through and see what's available and make sure it has a good fit for what we want in our orchards. So not all new technology will provide gains. Understanding what works and what does not is going to be a very important path for the future. We need to make sure it's commercially available. We need to make sure it's cost effective. We need to make sure it can create decisions or actionable outcomes. And again, it's got to be focused on efficiency and effectiveness. It's got to make improvements in the orchard. If it's not doing that, we've got to ask ourselves why we're introducing it. And it's got to be adaptable to the orchard system. Something that's going to work for the team of people that you've got, or the management team. And in the end, it's got to be something that adds value to the business. If it's not adding value to the business, then you've got to question, is it just something we're buying because it's nice and shiny and cool and new? And there's a lot of that stuff out there. So we need to be careful. It is going to be part of the solution, but we just got to make sure that it doesn't become part of the problem. So when we're targeting future excellence, why are we doing this? It's basically about making sure it's about health and well-being of the community and the environment, and just overall the sustainability of the business, of the local business and your own business itself. The things we need to understand. What are we going to do? We need to understand local and global requirements, where we are actually sending our fruit, what's going to happen in through those areas, where's the best place for us to be supplying. We need to create seamless integrated systems with a big focus on waste, minimising the waste of either fruit or stuff that we're actually using in the orchards, but we also need to focus on the consumer and make sure that we've got the right balance of taste, nutrition, and all those things that the consumer is actually looking for. So again, got to be absolutely key to targeting excellence in the future. And how are we going to do that? It's about implementation of technology and innovation. As I said before, it's making sure that we actually are implementing what needs to be implementing. It's following on and finding the correct solutions, and then learning those solutions and applying them in the orchards as they should be to help make those improvements. It's all about getting the right policy. It's about it's all about understanding policy and making sure that we're keeping up with it. It's about public demand, and it's about industry leadership and where we all need to go for the future. So when we're targeting what the best orchards are looking at, they look at excellence. Basically, it's about a business focused on quality, climate, orchard, and labour needs. We've got a continuous improvement focus using ideas and technology, which creates a culture of targeted excellence. Thank you.
Thanks very much, Jonathan. I think you've set some big goals and identified a lot of key decision-making points in that presentation, which was a great summary of the Future Orchards program that over the last few years. Is there anything that you can identify that the Australian growers have, where the Australian growers have made the most improvement during your time with the orchard program, Future Orchards program?
So for me, the big thing is actually Australian growers understanding that they don't actually have upper limits. One of the things I noticed when I first got over is that this idea of growing an 80 or 90 or 100 tonne crop in Australia seemed to be almost impossible, but now we're seeing examples of it across many different regions, and yeah, that's cool. And I think that we're going to see in the future that those things will actually change again, and people will, and it doesn't necessarily have to be yield, it will be quality, it will be all sorts of different bits and pieces, it will be efficiencies, but it's the believing that you can do it. It'll be water efficiency, it'll be labour efficiency, it'll be all those things, but I'm seeing such great things being done in all sorts of different places in Australia. But you've got to believe. If you don't believe, it's not going to happen. So.
And try it. I noticed that Stephen has turned his microphone on, so I'll just check if you've got any questions from your room, Stephen. Everyone's a little bit shy on the Q&A, so if you've got any questions and you're listening online, please type them in
Yeah.
You can even
Rose,
do it anonymously.
Rose, one of the growers asked me, Trent asked about water efficiency. We've got shallow sandy soil and a water shortage, and that's our limiting factor. So I know Nigel talked about irrigation, but that looked like different districts where they had plenty of access to water. So our limiting factor is and has been and will be water. And I think in future that's where we've got to focus. I'll give you an example of what some of our vegetable growers have done the past couple of years. The tomato growers are growing tomatoes in little pots, little bags. It costs another $15,000 a hectare, but they can cut their water use in half, which means they can grow twice the area. I'm not saying that we're going to grow apples in bags, but we think differently. Yeah. Thanks, Trent.
Do you have any comments on that, Jonathan?
Yeah, for me, I mean, I think you look at that in two directions. One of them is exactly what Stephen was saying, is about how do we get the best out of the water we've got. And some examples I've seen over here where there might be some blocks that you just have to sacrifice. There's some blocks that aren't particularly financially sustainable, but you're keeping them going. So you may be best to actually put a good amount of water on a block that's much more profitable and make your business more sustainable by making sure that that water that is being used where it should be used. So it's a bit of combination of both. It's maybe you have to be a little bit ruthless on the block that you've been keeping in, it's never really been particularly good, but it's still there. And then other solutions that might be how to get more efficient. So,
are there any other comments from your room, Stephen?
No, it's going well. Good presentation. Thanks.
Great. Okay, well, in the interest of time, thank you very much, Jonathan. We'll come back to you shortly for the orchard walks. And now I'll hand over to you, Stephen. So Stephen, for those of you who are new to the Future Orchards program listening online, Stephen is the frontline advisor for Stanthorpe, part of the Future Orchards program, and he's been conducting demonstration trials that he will now share with us. Thanks very much, Stephen.
Thanks, Rose. So we were faced last winter with water shortages and predictions of the drought continuing. So some of the orchardists decided they'd push some blocks out, others were going to thin differently, and others were going to buy extra water. But the question for our trial was, what if we reduce the crop load drastically? Could we get better quality? Because it's not just yield that suffers, it's quality. And that's the trial that we did. So we had two varieties, Galas and Pink Ladies. They were trickle irrigated, they were good orchards, but the water availability wasn't going to be good. So we thinned to 2 to 5 crop loads. A normal crop load, 80%, 60, 40 and 20% of that. I must stress that the normal crop load was done in consultation with the grower based on the normal things, the tree size, but also the coming season. So it was probably 70% of his normal crop load in a normal year. We did the thinning with NAA, brevis and hand thinning. And at harvest, we looked at yield, and the major quality issue was this drought-induced cracking that I'm sure you all see. Okay, what did the yield look like? Well, it was quite dry. So I'll put this up so you can see the growing season really, and it starts back in May when you've harvested the last apple. And those numbers on the bottom is the deficit compared to what we usually get. And you can see that in September we got 1 mil of rain. In November we got 6 mil. So it was extremely dry season. Rose, can you see on the right-hand side that climate? Yep.
It goes to total, which is rainfall, and beyond that, I can't see the table.
No, that's good. I just had someone's face there. I've moved it. So the rain came in February, and we had 152 mil, but it all came in a couple of short, sharp events, and that had an effect on yield and quality. And it wasn't all positive. So the messages are it was a very dry season and the rain came in a couple of lumps. This is the blemish that people would usually get in a drought. Galas on the top, pink lady on the bottom. And the blemish in the gala quite often starts out as russet and then turns into cracking as the apple expands. And as you'll see, that's what happened when we got the big lumps of rain about a month before harvest. The apple grew pretty quickly and it all cracked. The pink ladies, there wasn't as much cracking, but everyone's seen that on the right-hand side there, that apple, it's totally unmarketable. On the bottom axis, you'll see there's a normal crop load on the left and the very, very light crop load on the right. And as you would expect, the lighter trees had a bigger fruit size. But they're not that much bigger. They didn't go from an average of 59 to a 70. They only went to a 63. That surprised us. And the percent marketable fruit, we base this on the amount of cracking, and we got more marketable fruit with the very light crop load. But once again, only a bit more, went from 20% to 34%. And we had to really get a really light crop load to get that improvement. So there's a couple of reasons for this. I think the rain came too late. It came in too big a lump. And this variety loves to russet in a normal year around the stem, which you can live with a bit of it, but in a drought year, it turns into cracking. So, as you'd expect, the first conclusion, lighter crop load, you get a bigger fruit. Very high percentage of galas had some degree of stem end cracking. The rain just before harvest may have worsened that. Reducing the crop load certainly increased the percent of marketable fruit, but only a small proportion. And it's very unlikely that we put the economic numbers on that the increases in size and marketable fruit, small that they were, would compensate for the large yield reductions. What would we do in similar circumstances? Well, in hindsight, with these galas, I think the grower would decide not to thin drastically, but to completely remove the crop in some blocks and use that water in other blocks. Just what Jonathan said before, you've got to concentrate on your good blocks. It could be that gala is very prone to this. It's only ever a naturally medium-sized apple, and they always have a bit of stem end russet, and in droughts that can get worse. So that's what happened with galas. Okay, pink ladies. The average fruit size, quite predictably, with the increased thinning, we got bigger fruit, and this was quite useful. Went from 111 millimetres to 130 millimetres average, which is significant. The yield, the normal crop load was 65 tonne. That's what we picked off those trees, and the more we thinned off, the less yield we got, as you can see and as you'd expect. Okay, the russet. I crunched the numbers to combine the incidence and the severity of the russet, and we didn't really get a reduction, an increase in a reduction in the stem end russet score on the lighter crops. So why is it so? Well, I think it's to do with the time that the pink ladies got the rain. They were quite hard, small and green in January, February, compared to the galas that were close to harvest. So the percent marketable fruit, we at the very lightest crop, we got slightly more marketable fruit. But if you look at that bottom right-hand graph, really, there was 85 to 90% marketable fruit, which is pretty good, regardless of the crop load. So I think it's the timing of the rain and it's variety related. So there was no clear trend for lighter crop to have less russet and cracking. When the rain does come, it's important when it comes and how it comes. 8 weeks before harvest, didn't cause cracking. Having said that, if it hadn't have rained, I think the yield would have been substantially down. What would we do again? Well, I think with Pink Lady, they're far more robust to drought. We've intuitively known that. It could be because it was bred in Western Australia. If it was going to be a soft apple regards to hot, dry summers, it wouldn't have been selected. We know it grows well in the Goulburn Valley. And in hindsight, I think the grower would decide not to overthin and crop them normally, this adjusted normally, and know that he wouldn't get the quality issues, but may have some fruit size issues. So I'm happy to take any questions.
Thanks very much, Stephen. That was very comprehensive. I really appreciated the interpretation of the data too. Does anybody have any questions? Jonathan or Nigel, if you've got any questions as well? Anybody online?
No, just a comment from me that backs up exactly what you found there, Steve. Our experience on Pink Lady is it's very tolerant of drought situations, especially compared to something like a Royal Gala. So you know, that might be part of your strategy is working out where your value point is. But you know, if anything's going to be able to tolerate a bit more, it's probably your pinks for sure.
I will say thank you to you, Stephen, because that's probably a little out of my area of expertise at this point. So I don't have any questions to ask you, but thank you very much for sharing that data with us. I think some of the orange growers would also be very interested in some of that data from the drought responses of the different varieties, which we can look into sharing with them. So I will now hand back to Jonathan, and who will take us to New Zealand from the comfort of our own chairs.
So this is another one that this is Ross, and we've gone to Mark Erickson's block. So as you know, Mark's been around and had a bit of a catch up with you guys. I think it was a couple of years ago. Great character. So yeah, if we have a look at this and look at the block that Ross and Mark have been working together, and go from there.
Okay, welcome everybody. We're here at Waimar Orchard with Mark Erickson, the owner of Waimar, on my right, and Warren Grant, who's the orchard manager, on my left. Welcome Warren, Mark. And we're here in a beautiful sunny Hawke's Bay day today to go through with Mark and Warren one of the blocks of jazz that's on their property, because as you'll hear later, it's a real standout. But first of all, before we get into that, Mark, can you just give us an introduction of Waimar and how the property's evolved to where it is? Thanks, Ross.
As everyone on the Northern Loop knows, I like to correct Ross every so often, so I'm going to correct him and say I'm a part owner of Waimar Fruit Company, Waimar Orchards, in conjunction with my mother and father. So yeah, my wife and I run it with my mother and father, and fourth generation on this property, so caretakers of the land. Waimar in Māori means clear white water. So we're very fortunate. We've got beautiful soils here, and Ross and I have been in partnership together for the nurturing of these crops for probably the last 15 years. So yeah, Warren, our assistant manager, he's been with us for 2 years, and he's got an abundance of knowledge with tree husbandry and a lot of technical aspects too.
This has been a stunning block in terms of its productivity and profitability now for 3 years in a row. And just to give you some idea, the jazz average in this region averages about 65 tonnes per hectare. Normally it packs out pretty well, about 80% class 1. This particular block that's behind us has been doing somewhere between 100 tonne, and this year it did 115 tonne gross per hectare. It packed out at around 85% class 1. The colour was good and the fruit size was good. So although the yield was very high, way higher than the average, nearly double the average, the fruit quality was superb. So we just want to discuss what they think has actually contributed to this block being such a high performer. So Mark, what do you reckon it's down to?
Well, we talk about the 3 C's, so calm, consistent and canopy.
Yeah, I reckon we should go in and have a look at the trees, Mark, and have a look at what, you know, what's part of them. So let's do that. Another thing I'd like Mark and Warren to talk about is how they get down to their crop load target, because I think this is one of the fundamentals, is Waimar gets down to their optimum crop load target more quickly than a lot of other growers do, and I reckon that's putting a lot of the resources that the leaf, that the tree produces into the fruit that they want to harvest earlier on. I think that's quite significant, but you know, you want to explain how you do that, Mark. First with the chemical thinning, and then how Warren manages to get that fruit number at hand thinning. So yeah.
So yeah, Ross and I, we have these different recipes from the year before or the year before that. We just keep refining things. It's a living document effectively, and what's working for us doesn't necessarily mean it's going to work the year after, but hand in hand it's been working well for us. The girdle's actually been a real big positive and a big part of that success, because it's given us a reliable flower number and strong flowers going into the chemical thinning. So Ross and I, we come up with those recipes, we try to get the crop load down very early, so the primary sprays are very important to us, and Ross and I will come up with a figure. Sometimes I might put a little bit extra in there as a bonus, what I call the feel-good factor. But I am quite an aggressive chemical thinner, because for my way of thinking, if you can get the crop load down as quick as you can without overdoing it, because it's all about making sure we've got our canopy full with fruit, then obviously it's going to pay us big dividends down the track.
Okay, another little advertorial here for OrchardNet. So Waimar are very good users of OrchardNet. And every year, every block has a target of what they're going to farm to. And this particular block, we set a target last winter actually, that we wanted to farm to about 110 tonnes per hectare of a 162 gram piece. And as you look at this tree, and perhaps Jack can sort of show you the tree, to achieve that sort of number, we needed to harvest, we thought, about 425 fruit a tree. Now, you don't always get what you thin to in a bin. There's always this pick out that we call it. But last year, Warren, as the orchard manager, had a target to thin these to, and the target was 483 fruit per tree at thinning. So you got it right, Warren. You want to just tell us what you did to actually achieve that?
Yeah, just following on from that, Ross here. Ross does very good work setting up these plans with OrchardNet for what we want to thin to. We'll do pre-counts after we put a chemical thinner through before we hand thin, and we'll get a feel for what we need to thin to on the tree. Whether what we aim for is ideally everything in singles, but that's not always possible. Having done the pre-counts, we garner some good information throughout the block. We set up a recipe of how we're going to hand thin and what number we're going to hand thin to. We'll set up very simple rules for the thinners when they come in for their hand thin, and we'll stick to those rules and monitor that very closely.
Okay, so everyone loves a pruning demonstration, so now we're going to do a pruning demonstration on these trees, take you through what we're doing. Just to give you the fundamentals, we're actually targeting 115 tonne this coming year. We reckon on this block we need about 2.5 buds per fruit. That's where we've been the last few years, and we're happy with the vigor cropping balance that produces. So that means we're targeting about 1150 buds per tree. And we've got to leave the best 1150 buds on the tree. We've got to prune the tree so there's good light to all parts. Typically, this is a 3.7 metre row spacing. We've decided that the tree cropping height wants to be no more than 4.1 metres. which Warren's got a measurement on his hydroladder. So 4.1 metres maximum height. We're aiming for 24 branches in the tree, and now Warren's going to take us through how he achieves those goals.
Yeah, we can't stress enough the importance of good consistent pruning. So I'm just about to remove a dominating branch here in the upper part of the tree. We take our big cuts out of the tree first. I'll normally go through with a chainsaw actually, throughout all the blocks, and make those decision cuts. So then when we send the pruners through on ladders, they are not having to think too hard. We'll set them some very simple basic rules. There's another removal of a branch here. That's my 2 cuts up here, and now I'm ready to prune the top of this tree. We always seal our cuts with a bit of what we call Garrison. There's also a product called Back Seal, just to protect the tree against any disease. Starting at the top here, we'll leave what we call one sap drawer on the centre of the tree, and I'll remove any long upright growth first, or anything very close in to the trunk, and then I'll just follow my branch along and look for big spur clusters or wide arms which aren't required. And then I'll just move my way down the tree, follow each branch and be systematic in how you prune. Then things are not overlooked and missed. The rules that we apply for our what we call our detail pruning, we take any upright branches that are right along the plane of the branch. Anything that's laying along the top of the branch that's long and rank we'll take. We'll try and leave side arms where we've got nice open space and light. And then on the ends, we sometimes will single the end off. When we've got competition here, we want to reduce the bud numbers. The only other rule we have in here, when we have far too many bud numbers and bud density, is we will halve up some of these bud clumps, or sometimes total removal. In this situation here, I'm just going to remove this particular clump here and halve it, instantly reducing the numbers. I might even do the same here and just halve that, just to reduce the numbers at thinning time. Yep. Here we go now. So I make my decisions on the fly as I go, and I'll follow each branch. And over the top here has to go a young branch like this. We want it to grow more, so I'm going to run it very slender. Once I've done my main cuts off here, I'm just going to double check if there's anything I've missed. I might do a few spurs in there, a couple in there. Maybe I'll get rid of that one, I don't like that one now, and just leave that spur. That's a finished product.
Thanks very much, Jonathan. Does anybody have any questions in your space, Stephen? Gone quiet again on the Q&A session.
Yeah, can you hear me? Can you hear me, Rose?
Yes, yes.
Wayne Thomas asked a question about light interception. I noticed that the rule of 6 branches per metre applied, because there are 4 metre trees and 24 branches, but the spacing's only 3.7 metres. It's not common that we go that we would go that high and still get good colour. And I know New Zealand doesn't get strong light like we do, but just a comment, Ross or Jonathan, do you get shading on the fruit colour on the bottom of those trees we just saw? They seem to be a bit tall for the spacing.
Yeah, so those blocks there, the key part of it is getting, like you say, is getting light penetration to the bottom of the tree. As you saw, there was a huge focus on ensuring there was very low vigour. So while he was cutting off some reasonable branches that were sort of maybe this long, a lot of the stuff he was getting was only 200 mils of growth, 250 mils of growth for the year. So at that level, it's not an issue. And you do have a double-edged sword, because if in the conditions we have, where we have a lot of vigor, if you keep cutting a tree back and making it smaller, you induce vigor as well. So that block will have reflective mulching through it every year to make sure there is light through to the bottom of the tree. And it has been girdled to control the vigor. So vigor control in that block is quite a high focus, but if you can control it, you keep the light through the tree for the whole year. And anything that's just too aggressive and too strong is removed. So what we're trying to do is keep small, calmer branches in the tree. Many of them, but it's a grunty piece of ground, and if you cut that tree short, you'd still end up with a vigor problem and poor light in the bottom of the tree too.
So Jonathan, they were M9, were they?
I have a feeling that might be 202. Yeah, I think it's 202 block.
Thanks.
Any other questions from your end, Stephen?
No, that's it. Thank you.
Everyone's gone shy. Okay. Do you have any other comments that you'd like to share, Jonathan? Otherwise, we might wrap it up for the day.
No, just the one you put a comment through about how do you teach people how to prune in those sort of trees. It is an absolute key part of it, is that you go through and you make rules simple and able to be transferable to your pruners, because there's no point creating systems where you can't make simple rules. So that's it. You can have the system that's the best in the world, but if you can't teach other people to do it, it's not going to be transferable.
Can we help get a robust root evaluation trial? Yes. So there is through the upfit program, there are trials happening around the country. I don't know if they're in Stanthorpe or not, but I will look into that and get back to you. I agree with you, Daniel. I will speak with Tom, who looks after the upfit program, and I'll get back in touch with you about the rootstock trials. Do you have any other comments about that, Stephen, about the rootstocks and the availability in Stanthorpe?
Well, I think our availability is as good as anyone else's. There is a bit of a logjam at the nurseries, but we need to know how they're going to perform. So we need to have them evaluated, and they're long-term trials. It's not something that we can do in the future orchards, in a year or two.
No.
But we've got to get them started. We've got to get them funded. So.
Yeah. So I know that there are trials underway in some regions. I'm not sure which regions, but I'll find out about that and get back to you. I know that I've seen some in the Goulburn Valley, and I know that there are some I'm fairly sure in Queensland as well. So I'll get back to you on that. So thank you, Jonathan, Nigel, and Stephen, for sharing your experience and insights. I'd also like to acknowledge that this project is funded by Irrigation using the apple and pear R&D levy contributions and contributions from the Australian Government. We have more webinars coming up over the next few months as the travel restrictions continue, and you can see a summary of those here. So next week we have a webinar on alternative controls to apple replant decline, and following that there's one on drought and how other industries have managed to more efficiently use water, which may be quite relevant to some of you guys. If there's anything else that you're interested in, please let us know. Get in touch with us at APAL. In the meantime, stay healthy and safe, and we look forward to seeing you hopefully in person in September or at one of the upcoming webinars and orchard walks. Thanks very much.